Cool. Thank you. So my name is Emmet Golden-Marx. I am a postdoc at Tsinghua University, and today I'm going to give you a brief introduction to probing the morphology-density relationship at Z of 2.3 with MAMMOTH protoclusters. So just to introduce, MAMMOTH is a sample of about 3 protoclusters at redshifts 2.3. Each of them were identified using strong Lyman alpha absorption features, and each field has been observed with HST as well as a large subset of other bands, but I'm going to be using the HST observations to probe the galaxy morphology. So fundamentally, when we talk about galaxy evolution, we tend to think of our galaxies being quenched, and we tend to think of that by color. So there's been lots of studies of the buildup of the red sequence out to high redshifts, out to Z of 2 and beyond, but very little has been done to probe galaxy morphology. And fundamentally, just like red sequence galaxies are more commonly found in over-dense environments, so are morphologically elliptical galaxies. So the question is, when does that get set into place? Do we see that in protocluster environments, or do we see that in later on? So to do this, we estimate the Sersic index of every galaxy in our field, each emitter. And you can see we have our model here that shows how we take our galaxy, the model galaxy, and then the residual. And we use that using GalFit, and we measure that for each emitting galaxy. Can I go to the next slide? Thank you. So once we have our measurement of morphology for each galaxy, we then wanted to look, do we see sort of any kind of substructure within our protoclusters, where the most bulge-dominated galaxies, those of the Sersic index greater than 2, are they commonly found clustering around one another? So we did this for all 3 fields. I'm only showing 1 here, and you can see that there's really no strong trends in these 2 plots, where we're seeing on either the local density or what fraction of galaxies within the 5 nearest galaxies have a Sersic index greater than 2. And there's really no strong trend, so no sort of subclustering within our protoclusters. But we also then look at the merger fraction, the plot on the right, and we see a relatively constant fraction of merging galaxies. But this is purely looking at the subclustering within our protoclusters. So then we are working right now on comparing to the field to see, do we see any sort of relative differences between the field and the protoclusters. And here we do see, again, an increased merger fraction, but we actually find fewer bulge-dominated galaxies relative to the field, although we are still working on this. So what this might mean is that, in general, for the protocluster environment, it's not going to be causing morphology changes, but it is going to be causing an increase in mergers, which could then eventually lead to a greater number of morphologically elliptical galaxies. So with that, I will leave you with that. Please feel free to come chat with me on my poster. I'm happy to discuss any of this. Thanks so much.